Next problem. Consider two random process x of t which is equal to 3 cos omega t plus theta and y of t is equal to 2 cos omega t plus theta minus pi by 2, where theta is a random variable uniformly distributed in 0, 2 pi. Prove that root of r xx of 0 or yy of 0 is greater than or equal to r xy tau. Given that x of t is equal to 3 cos omega t plus theta and y of t is equal to 2 cos omega t plus theta minus pi by 2. Take it as equation number 1. Also given that theta is a random variable uniformly distributed in 0, 2 pi. So the PDF f of theta which is equal to 1 by 2 pi minus 0, where theta lies between 0 and 2 pi, 0 otherwise, is equal to 1 by 2 pi, theta lies between 0 to 2 pi, 0 otherwise. We know for the uniform distribution, if theta is lies between a and b, that is lower limit a and upper limit b, then the PDF of uniform distribution f of theta is equal to 1 by b minus a, where theta lies between a and b, 0 otherwise. Here we are taking a as 0 and b as 2 pi. We are using that same formula. This is equation number 2. Now r xx of tau which is equal to expected value of x of t into expected value, x of t plus tau. We are giving the values of x of t from equation number 1. We will get 3 cos omega t plus theta into 3 cos omega t plus tau plus theta. The second term we are replacing t by t plus tau, which is equal to 3 into 3, 9. We are taking that 9 from 9 outside from the expected value. So expected value of cos omega t plus tau, cos omega, multiplying omega with each and every term. So cos omega t plus omega tau plus theta, right? So which is equal to 9 into expected value of cos a cos b formula of cos a plus b plus cos a minus b. Here a is nothing but omega t plus omega tau plus theta and b is equal to omega t plus theta. So we will get 9, 1 by 2 is constant. So we are taking outside 9 by 2, expected value of cos omega t plus omega t, 2 omega t plus omega tau, theta plus theta, 2 theta. The second term, cos omega t plus cos omega tau plus theta minus omega t. We are taking the minus inside, omega t minus theta, theta, theta get cancelled. So 9 by 2, expected value of cos 2 omega t plus omega tau plus 2 theta plus cos omega t. Because theta, theta get cancelled, theta minus theta, right? Omega t minus omega t get cancelled. So 9 by 2, expected value of cos 2 omega t plus omega tau plus 2 theta plus expected value of cos omega tau. We are separating the expectation to each term. Cos omega tau is a constant. So expected value of constant is nothing but constant. So the second term becomes plus cos omega t. Remaining terms as it is, right? Now we are having a expected value of cos 2 omega t plus omega tau plus 2 theta. We know expected value of x which is equal to, for the continuous random variable, integral whatever the limits, x into, that is expected value of x is nothing but x into integral x into f of x, right? That PDF into dx. Here instead of x we are having cos 2 omega t plus omega tau plus 2 theta. So integral limit is, we know, 0 to 2 pi, 9 by 2, 0 to 2 pi cos 2 omega t plus omega tau plus 2 theta into that PDF f of theta into d theta. Second term as it is cos omega tau. Now 9 by 2 cos integral 0 to 2 pi cos 2 omega t plus omega tau plus 2 theta into f of theta, we know 1 by 2 pi into d theta. Second term as it is cos omega tau. So we are taking 1 by 2 pi outside the integral because constant. So 9 by 2 into 1 by 2 pi integral 0 to 2 pi cos 2 omega t plus omega tau plus 2 theta into d theta plus cos omega tau. We know integral cos a plus b plus cx into dx, which is equal to sin a plus b plus cx by c. So here a is equal to 2 omega t, b is equal to omega tau, and cx is nothing but 2 theta. C is 2 and x is theta. So applying that integration, we will get 9 by 2 1 by 2 pi sin 2 omega t plus omega tau plus 2 theta by 2, lower limit 0, upper limit 2 pi, second term cos omega t, omega tau, right? 9 by 2 into 1 by 2 pi sin 2 omega t plus omega tau, we are giving the upper limit to theta, so 2 into 2 pi divided by 2 minus sin 2 omega t plus omega tau plus 2 into lower limit 0 by 2 plus cos omega tau, which is equal to 9 by 2 1 by 4 pi sin 2 omega t plus omega tau 2 into 2 4, so 4 pi minus 2 omega t plus omega tau plus cos omega tau. So 9 by 2 into 1 by 4 pi, because in denominator we are having 2, so 2 pi already there, 2 into 2 pi 4 pi, right? 1 by 4 pi. We know sin of 2 pi plus theta is sin theta, sin of even number of 2n pi plus theta, which is equal to sin theta, 2n pi plus x is equal to sin x. So here 4 pi plus 2 omega t plus omega tau, so here 4 pi, instead of x we are having 2 omega t plus omega tau, so we will get sin x, sin 2 omega t plus omega tau. Second term as it is minus sin 2 omega t plus omega tau plus last term cos omega tau. So rx6 of tau, which is equal to 9 by 2 last term cos omega tau, because sin 2 omega t plus omega tau minus sin 2 omega t plus omega tau get cancelled, we will get 0, 0 into 1 by 4 pi, which is equal to 0. So we will get 9 by 2 cos omega tau, which is a function of tau. Now we need rx6 of 0, which is equal to 9 by 2 cos omega 0, cos 0 0, cos 0 sorry, cos 0, which is equal to 1. So we will get 9 by 2 into 1, so 9 by 2. Now ryy of tau, which is equal to expected value of y of t plus tau, which is equal to e expected value of 2 into cos omega t plus theta minus pi by 2, 2 cos omega t plus omega tau plus theta minus pi by 2. Here 2 constant, so 2 into 2 4 constant, we are taking it outside from the expectation. So 4 into expected value of cos, first we are bringing pi by 2 friend, right? So taking minus outside from that first bracket, so cos minus pi by 2 minus omega t plus theta, right? The second term also same thing, we are bringing pi by 2 in front, so cos of we are taking minus outside, so cos minus of pi by 2 minus omega t plus omega tau plus theta. We know cos of minus theta is cos theta, that is cos of minus x is equal to cos x. So we will get 4 into expected value of cos of pi by 2 minus omega tau plus theta, second term cos pi by 2 minus omega t plus omega tau plus theta. Now cos pi by 2 minus theta, we are using that formula, cos of pi by 2 minus x co-ratio, instead of cos you will get sin, so sin x, pi by 2 minus is the positive value, so sin x. So 4 into expected value of sin omega t plus theta into second term sin omega t plus omega tau plus theta, right? So now we will get, that is equal to 4 into expected value of, now we are using sin a sin b formula, so 1 by 2 cos a minus b minus cos a plus b. A is nothing but omega t plus omega tau plus theta, and b which is equal to omega t plus theta. So 1 by 2 cos omega t plus omega tau plus theta minus omega t minus theta. We are bringing minus inside. So in the first bracket omega t and theta get cancelled. Second one minus cos A plus B, omega t plus omega tau plus theta plus omega t plus theta. So 2 omega t plus omega tau plus 2 theta. So we will get 4 by 2 cos omega t, the expected value of cos omega t minus cos 2 omega t plus omega tau plus 2 theta. As usual, cos omega tau is a constant with respect to expectation. So expected value of constant is constant. So 4 by 2 cos omega tau minus 4 by 2 expected value of cos 2 omega t plus omega tau plus 2 theta. So 4 by 2 2 cos omega t minus 2, again we are applying expectation formula, integral 0 to 2 pi cos 2 omega t plus omega tau plus 2 theta into f of theta is 1 by 2 pi into d theta. So 2 cos omega t minus 2, 1 by 2 we are taking outside. So 2 by 2 pi cos integral cos a plus b plus cx dx is nothing but sin ax plus b plus cx by c. Same formula. So sin 2 omega t plus omega tau plus 2 theta by 2, lower limit 0, upper limit 2 pi. Applying lower and upper limit as it is, right? 2 cos omega t minus 1 by 2 pi. So we are applying upper limit sin 2 omega t plus omega tau plus 4 pi minus sin 2 omega t plus omega tau into 2 into 0, that is 0. So we know sin 4 pi plus theta sin theta. So we will get 2 cos omega tau minus 1 by 2 pi sin 2 omega t plus omega tau minus sin 2 omega t plus omega tau. So sin 2 omega t plus omega tau minus sin 2 omega t plus omega tau becomes 0. The second term becomes 0. So you will get 2 cos omega t, which is a function of tau. So r y of 0, which is equal to, so 2 into cos 0, that is 2, because cos 0 is equal to 1. So now r of xy of tau, which is equal to expected value of x of t, y of t plus tau, right? That is equal to expected value of 3 cos omega t plus theta, 2 cos omega t plus omega tau plus theta minus pi by 2. Now we are rearranging the second term. So we are taking pi by 2 in front. So minus pi by 2 minus omega t plus omega tau plus theta. So cos of minus theta, that is cos theta, and cos of pi by 2 minus theta sin theta. Cos of minus x is equal to x, and the cos of pi by 2 minus x is sin x. So we are using the same formula. So 3 into 2 6, we are taking 6 outside the expected value of cos omega t plus tau into sin omega t plus omega tau plus theta. So we are using cos A sin B formula. So r sin A cos B, right, which is equal to 1 by 2 sin A plus B plus sin A minus B. So A is nothing but omega t plus omega tau plus theta, and B is nothing but omega t plus theta. So we will get 6 expected value of 1 by 2 sin 2 omega t plus omega tau plus 2 theta plus sin omega t. So finally we are splitting the expectation. So 6 by 2 expected value of sin 2 omega t plus omega tau plus 2 theta plus 6 by 2 expected value of sin omega tau. Sin omega tau is a constant with respect to expectation. So last term you will get 3 sin omega tau. Then the first term we are using the expected value, that formula for continuous random variable. So 3 integral 0 to 2 pi sin 2 omega t plus omega tau plus 2 theta into f of theta. F of theta is nothing but 1 by 2 pi. We are substituting that value and taking the integration as we see in before, right? So 3 into minus cos 2 omega t plus omega tau plus 2 theta by 2, lower limit 0, upper limit 2 pi, because integral sin theta is nothing but minus cos theta, right? The formula, same formula, but sign will change. For sin, integral sin you will get minus cos, integral cos you will get sin, right? So we are using that formula plus 3 sin omega t So we are using upper limit. So 4 pi minus cos 2 omega t plus omega tau plus 4 pi minus cos 2 omega t plus omega tau 2 into 0 0, right, plus next term 3 sin omega t. We know cos 2n pi of x is also cos x. So we are using the formula. So 3 by 2 minus cos 2 omega t plus omega tau plus cos 2 omega t plus omega tau plus last term 3 sin omega tau. So Rxx of tau, which is equal to 3 sin omega tau, the function of tau also. So here cos 2 omega t plus omega tau minus cos 2 omega t plus omega tau become 0, right? So that is equation number 5th. So equation number 5. So from 3, 4, we will get Rxx of 0, Ryy of 0 is equal to 9 by 2 into 2, 9. So Rxx of 0 into Ryy of 0 square root, we are taking square root of 9, which is equal to 3. That is equation number 6. From 5, R modulus R xy tau, which is equal to modulus 3 sin omega t, which is equal to 3 modulus of sin omega t. 3 is a positive number. We are taking outside from the modulus. We know maximum value of sin omega t, that is modulus value, is 1, because sin theta lies between minus 1 and to plus 1. Lower limit for sine wave, sine curve, minus 1 is the least and plus 1 is the maximum, highest. So we are taking modulus sin omega t, so we are taking the maximum, that is 1. So 3 into 1, 1, which is less than. So Rxy tau, which is less than or equal to 3. 3 is nothing but, we know from the equation number 6, root of Rxx of 0, Ryy of 0, right, which is to be proved. So thanks. We'll see in the next video.